Okay, so we're now going to prove that a set E is open if and only if its complement is closed. So let us first suppose that E complement is closed. We want to show that E is then open. So that is that every point in E is an interior point. So let us choose a point X in E. So since obviously X is in E, then X is not in E complement, and so X is not a limit point of E complement. And why is that? Because we know that E complement is closed and therefore it contains all its limit points. So therefore X can't be a limit point of E complement. So remember the definition of a point being a limit point of a set. Well, we know that since X isn't a limit point of E complement, then we can actually find a neighborhood N of X for which the intersection of E complement with N is empty. So thus there is a neighborhood N of X such that E complement intersection of N is empty. Well, obviously if that is the case, then this must imply that N is in fact a subset of E. So X is an interior point obviously of E, and E is open. So do you see how that followed? Because we managed to show that for any X I take in E, we managed to find a neighborhood on that point for which the neighborhood is a subset of E. Okay, now let us prove the converse result. So this time let us suppose that E is open. E is open. Okay, and now we want to show that E complement is closed. That is that every limit point of E complement is a point within the set E complement itself. Okay, so let X be a limit point of E complement. Of E complement, okay. Okay, then by definition, every neighborhood of X contains a point of E complement. So since that is the case, obviously X is not an interior point of E, because otherwise we would be able to find a neighborhood on X. So obviously the implication of this is that X is not an interior point of E, otherwise we would be able to find a neighborhood on X, which is a subset of E. So X is not an interior point of E. But then we know that E is an open set, which means that every point within E is an interior point. So obviously X cannot be in E, and X is in E complements. So we've just shown that any limit point of E complement is a point within the set. So therefore, E complement is closed.